Hello and welcome to this course on MATLAB programming for numerical computations. We are in week 12 of this course and this is the final video of this course. What we have tried to cover in this particular week is to take up a couple of examples to demonstrate to you what we have done in last 11 weeks is basically forms the foundation of numerical techniques, and you can use this to build upon various applications, various solutions for either for your classes, for your research, or if you are in industry, for your work in the industry. Okay. What I am trying to show you in the last few lectures is basically that these foundational materials that we have covered in the first 11 weeks, you can build upon them to solve certain interesting problems. Those are not the end point of it, but those are really the starting point for your journey into using MATLAB, or for that matter using any kind of a software for solving numerical problems. Okay. So, in this last lecture, what I am going to do is cover if you have PDEs in multiple variables, how do we tackle that? Okay. If you recall, week number 7 we talked about ODEs in single variable, then week number 8 we did ODEs in multiple variables. When we had PDEs and we solved them using method of lines, we converted them into ODEs and we converted them into n first order ODEs that we could then solve using MATLAB. Okay. What if we did not have one single PDE but we had multiple PDEs? How do we tackle that? Okay. Answer is fairly straightforward, because we are working with vectors. All we need is we need to have the appropriate size vector and appropriate equations. Once we have that, we will be able to solve any kind of a problem with any number of variables. Okay. That is the message that I want to give over here. Okay. So, now let us consider multiple first order PDEs. First order PDEs in 3 variables CA, CB, CC. Okay. So, what is happening over here is you have a reactor where A and B are going to get converted to a product C. Okay. At the inlet we have the concentration okay. This is what is given. Okay. Now, what happens is initially there is nothing in no concentration in the tube. Okay. So, initially the tube is empty, that is why CA, CB, CC is all 0. Okay. At time 0 you start flowing the CA and CB into the system, and as CA and CB flow in, they react with each other to form C. So, that is kind of the problem. Okay. So, what we are going to do is exactly what we have followed in the previous week. We are going to discretize this into n domains or n intervals. Okay. So, location 1, location 2, location 3, and n plus 1. Okay. At this location, what do we have? At this location, we have CA in, at location 2, what do we have? Okay. So, this is what we have. Okay. Now, let us look at this particular equation. Okay. If we were to use backward difference formula, we will have okay. Likewise, we write it for CB. So this is what we get, and likewise we will write for CC as well. Okay, we have to remember that our ODE 15S requires T and Y. Y is a column vector. Okay, so what kind of a column vector will Y be? Y will be CACBCC at 2, CACBCC at 3, CACBCC at 4, and so on up to CACBCC at n plus 1. Okay, and that's exactly what I have written over here that you can see. Okay, so I have CACBCC at 2, 3, and so on going up to n plus 1. That's our Y. Okay, if now we want to put our C, we'll have CA in followed by CACBCC, 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 and so on. Okay, so let's go on to MATLAB and try to solve this problem. I've already set up this particular problem for PDEs in multiple variables using method of lines, and these are the parameters that we talked about. Okay. Let's get 50 points as n. H is L by n. Okay. Why 3 into n comma 1 is because 2, 3, 4, 5 up to n plus 1 is n numbers, and each of this is 3. So that's basically what we have written. T span equal to 0, 0, like last time we will give 0, 0 0.5, 1, 2, 5. Okay, and let's write down the function. Dy is going to be equal to or okay 3 to end. Okay, so let's see what I have written. CA, CB, CC, Y 1 to 3 to end, CA sorry is 1 to 3 to end, CB is 2 to 3 to end, CC is 3 to 3 to end. What do I mean by that? Is what is CA? The first CA is 1 followed by skip 3, then go over here, skip 3, go over here, and so on up to this point. Okay, once we try to skip 3, 1, 2, 3, it goes beyond n, so it won't skip. So we are going to get the first location, fourth location, seventh location, and so on up to 3n plus 3n minus 2th location. Okay, what about CB? We'll start with the second location, then 2 plus 3th location, and so on up to this location. What about CC? We'll start with third and so on. Okay. Now recall what we had done in the previous week. Okay, the first nodal CA is CA in, the second nodal CB is CB in, the third nodal CC is CC in. Okay, and that is what we are going to put as well. Okay, So once we have that, so let's move our parameters up. Let's delete this. Okay. So CA is nothing but C in 1. Okay, I'll copy this, paste it over here. Okay, same thing with CB. CB is C in 2 followed by CB. CC is C in 3 followed by CC. Okay, so this is what we have. Okay, so let us initialize DCA, DCB, DCC also. Okay, now we have for I going from 2 to n plus 1, right. This is exactly what we had done in the previous week. Okay, so DCA I equal to DCB I equal to DCC I equal to. Okay. The common calculation is K multiplied by Ca multiplied by Cb. Okay, that is the rate of reaction. So we will say R is going to be equal to K multiplied by Cai multiplied by Cbi. Okay. Okay, and let us say the parameter over here is u negative u divided by h. That is okay, we can just calculate that. Okay, so what we have is negative u multiplied by Cai minus Cai minus 1 divided by h minus r, right. So minus u multiplied by Cai minus Cai minus 1 divided by h, Cai minus Cai minus 1 divided by h minus r. Okay, so that is the first guy. The second guy, let me copy this and paste it over here. For the third guy also we will paste this, Cb, Cb and again minus r, and we will have Cc, Cc and plus r, right. Why Cc, Cc and plus r? Again you look at this equation and you will get dci Okay, so this is what we get, and this is nothing but R calculated at ith location. So u multiplied by Cci minus Cci minus 1 divided by h plus R. Okay, so u multiplied by Cci minus Cci minus 1, the whole thing divided by h plus R. Okay, so that is what we have written. So now we have Ca, Cb, Cc, all of those calculated for these various values. Okay, now what we need to do is to get our dy. Okay, so what do we have? We have to calculate Ca, then Cb, then Cc, Ca, Cb, Cc, Ca, Cb, Cc and so on. Okay. So, we can do that in for loop. Okay. So, this is CAI, CBI, CCI that will be stacked below the original value of y, right, original value of dy. Okay. This is what we will get. Okay. Let us delete this. Okay. So, that is the function. Okay. So, that is what we have, that is initialized already, and so CA in was 1.2, 1 to 3 to end. Okay. Remember, this is exactly what we had done before. Let us keep it like this. I am sure I am going to get an error, but let us go step by step. Okay. So, let us run this, see where do you get. Okay. We got line 40, we have not defined h. Okay. Okay. H equal to L by N. Okay. Yeah. So, this is where we have a problem. Let us look at y sol. Okay, this is at time 0, this is at the first time, second time, third time, and so on. Okay, so that is what we have. Okay, so right. So, we will have to do at various times for I time equal to 1 to 5, CA is y sol I time Okay, so let's see what we have done. Okay, so at time 0, I time is equal to 1. Okay, at not t solve, it's going to be z. Okay, so this is the concentration of A, this is the concentration of A at time 0, at time 0.5, at time 1, at time 2 and at time 5. Okay. Now let us see what the concentration of C is going to be also. So I will hold this and I will run. Let us run and see. Okay. So these decreasing values are the values of A, these increasing values are the values of C. Let me actually not plot A and let me plot C. Okay. So these are the values of C that you get. Okay. So at 0, time 0, C is all 0. At time 1, C starts increasing, okay, and then again falls to 0. Then again it increases at time 1, falls to 0, and then at time 2 it increases and then it falls and doesn't exactly reach 0, and then after that it keeps increasing till it reaches its final value, and that final value is 0.7. So that's how CC looks like, and let's see how CB is going to look like. And this is how CB looks like. Okay. So CB looks quite similar to CA. Okay. Only thing is that it starts at 1.0 and falls to a lower value than CA does. But otherwise you will see that there is a similarity in the patterns that we observe with CA and CB. Okay. When I saw the structure of YSOL, that where there were 5 rows corresponding to the 5 times, that is time 0, 0.5, 1, 2 and 5.0, and there were 150 columns. What were the 150 columns? First column was CA, CB, CC at location 2, CA, CB, CC at location 3, CA, CB, CC at location 4 and so on. Okay. So for at first time we extracted the first row, the first location, fourth location, seventh location and so on formed CA, 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 CA. Second, fifth, eighth locations and so on formed CB, 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 CB. Third, sixth, ninth, 12th location and so on formed CC, 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 CC. Okay. So that's what I extracted over here. I extracted CA here, CB here and CC here and plotted them one at a time, and you could see what the plots were. Okay. So that is how you will solve multivariate PDE. I'm going to basically end my lecture over here with going back to what we have done. Conceptually, solving multivariate PDE is fairly straightforward. Instead of working with a vector that consists of one point at each node, we have a vector consisting of 3 concentrations at each node. Okay, 3, 3, 3, 3 n times made it a 3n sized vector. Okay, so the 3n size vector that we got at each particular time, we then extracted concentration of A at all n locations, concentration of B at all n locations, concentration of C at all n locations, and we used that to calculate our dC by dA by dt, dCB by dt and dCC by dt. We solved the overall problem using ODE 15S and we obtained the solution. The solution was number of time points as equal to the number of rows and 3 multiplied by n as number of columns. Okay, we then went ahead and plotted each and every concentration as desired. Okay, so conceptually though, what we have done in previous week, what we have done in 8th week of the course are very similar. Implementation wise, you have to do it, you have to think a little bit more carefully. Why? Is because you have a larger dimensional array. That larger dimensional array, you need to split it into multiple vectors. Each vector you have to resplit it to get the concentration CA, CB, CC, and then plot them against Z or plot them against time, whatever you want to do, you will be able to plot them and try to analyze the overall solution. Okay. So with that, I will come to the end of this particular lecture and indeed end of this particular course. What we have tried to cover in this course is to give you an overview of MATLAB and an overview of solving problems using MATLAB. Okay. This particular week, we have basically what we have tried to cover is really to demonstrate to you how we can use the fundamentals that we have covered in first 11 weeks and build them to solve more and more complex problems. The problem that I just showed you is a problem of significant complexity. I do believe that you have tools in order to solve and tackle problems of this nature. Okay, it does take a fair amount of time, effort and patience, and the way you would want to really master this is by solving more and more examples, solving more and more interesting problems. Okay, with that I come to the end of this course. I hope you have got a very good flavor of solving numerical problems using MATLAB, and I hope you will extend your boundaries beyond this course by trying to learn more and more things in this nice world of numerical programming. Thanks for watching these videos and see you later. Bye.